Hello, welcome to my channel Advanced Physics and Math, and now with a very important problem consists of a pendulum with a ball attached with a massless wire of length L swaying in a circular motion as shown in the video. The wire is making an angle theta with the equilibrium position. Remember that the wire has a length L and the distance between the ball and the rigid solid is L cosine theta. We used cosine because this distance is adjacent to the angle theta. And the distance between the ball and the reference, which is the ground at any time t, is L minus L cosine theta. Okay. Now, the aim of this question is to find the equation of motion of the ball through using Euler-Lagrange equation. And to use Euler-Lagrange equation, we must find Lagrange, which is the difference between the kinetic and the potential energies. So I must find the kinetic energy and the potential energy to find Lagrange. Now, the kinetic energy of the ball is half I omega squared, where I is the inertia of the ball, which is equal to ml squared, and omega is v over L. Omega is the angular velocity of the ball, I is the inertia of the ball, I equals ml squared, omega equals v over L. Substituting I and omega, we get the expression of the kinetic energy in translating movements. Here we get an exciting result. The kinetic energy of rotation equals the kinetic energy of translation. I can use any one I want, any decision I prefer, but here it's difficult to use the kinetic energy of translating movement because the ball is moving in 2D dimensions in the translating movement. It's moving with respect to x-axis and to the y-axis. So here, if I want to use the kinetic energy of translating movement, I must substitute v squared by x dot squared plus y dot squared, and it is difficult to use the kinetic energy for translating movements. So I prefer to use the kinetic energy of rotating movement, which is half I omega squared or half I theta dot squared, where omega equals theta dot in rotation. Now the potential energy of the ball is mg times this distance, which is the distance between the ball and the reference, which is the ground. Now I get the kinetic energy, the potential energy. I must find the Lagrange, which is the kinetic minus the potential energy. Lagrange is the kinetic minus the potential energy, which is I theta dot squared minus mgl 1 minus cosine theta. Now, to apply Euler-Lagrange equation, I must find some terms. The partial derivative of Lagrange with respect to theta dot is ml squared theta dot, because the second term of the Lagrange has no theta dot, and theta differs from theta dot. So the total derivative of ml squared theta dot with respect to time is ml squared theta double dot. Now the partial derivative again of Lagrange with respect to theta is minus mgl sine theta, because the derivative of cosine theta is minus sine theta. Now, substituting this term and this term in Euler-Lagrange equation, substituting ml square theta double dot instead of the first term minus mgl sine theta instead of the second term, I get ml squared theta double dot plus, because I have minus and minus, plus mgl sine theta equals to 0. For more approximation or for more simplification, I can divide the whole equation by ml squared to get theta double dot plus g over l sine theta equals to 0. Now, to deal with such equation in an easier way, I can use an approximation, and physics is a science that depends on approximations. So I can suppose that the angle theta is so small, so sine theta equals to theta for small angles. Then I can write theta double dot plus g over l theta equals to 0. Now I can substitute g over l by omega squared, where omega equals to the radical g over l. The solution of this second order differential equation is a, which is a constant, sine omega t, plus b, which is another constant, cosine omega t. The strategy we used to find this solution is in mathematical methodologies, or is a mathematical methodology we will deal with in the coming videos. Now, I reached my aim, which is finding the equation of motion of the ball, which is a sine omega t plus b cosine omega t. Thank you for watching. We will solve more advanced questions in the coming videos. To that time, stay safe and goodbye.